Okay, let us start with the okay. Today's topic is on sport vector machine, and tomorrow we will do some kernels of the SVM and the super. As we know that the supervised learning, and this one is your last topic for the ST1, and yes, from the first to 20th lecture, your ST1 will be covered. And for ST2, there is a lecture from the 21st to the 40th lecture. So in a ST1, we are covering the introduction to machine learning and the supervised learning. So till tomorrow, we are able to complete all the aspects of the supervised learning as well as the basic introduction to the machine learning. And let us begin with the code vector machine. Yes, now the first is a basic introduction to the sport vector machine. The sport vector machine, as we know that this is a supervised classifier which require the training data set, which requires the which require the training data set to train an algorithm. And in a machine learning, the sport vector machine are the supervised learner. Yes, as we have covered this. And with assertive learning, that that analyze data used for the classification and the regression. Basically, the sport vector machines can be used for the classification as well as for the regression purposes. And till now, we are hopefully you all are aware of that. What is the applications of the classification and what are the applications of the regression? And they analyze the SVM analyze a large amount of data to identify the pattern from them, and the SVM are based on the idea of finding. Yes, this is one of the main concept in a SVM. Uh, in a SVM sport vector machine, the entire concept is based on there is a identification of a or finding a hyperplane, which divides our data set into the two classes. And here we can see that in this figure, there is a class A there. There is a red stars which are representing the class A, and there is another class is there which are representing the class B. And there is a line in between that, and here you can see that this one is a line that whatever we are doing in existing algorithms, but here they are also defining the margin. Along with the line, the sport vector machines also defines the margin. And here you can see that this one is a your baseline, and this is a okay, this is a maximum margin, and this is a this one is a maximum margin towards the class A, and this is a maximum margin towards the class B. And how this margin has been calculated, that is based on the intersect with the some training samples. And these kind of samples are generally referred to as a sport vectors. So these three are the sport vectors to generate the hyperplane. So this one is this area is generally referred to as a hyperplane. So you must remember this point. What is the basic idea behind the SVM, and why we are using this hyperplane? plane. And basically, this one is used to divide the data set into the two classes. So now there is another slide which is more important. What are the basic applications of the sport vector machine? Now we can use the sport vector machines to detect the face, to detect the different features. We can definitely categorize the text into the or a hypertext into the different categories. Then we can use it for the classification. Sorry, we can use it for the classification of images, bioinformations. Yes, there is a protein fold and remote homology detection, handwriting recognitions, and uh, and there is a generalized predictive control. And yeah, there is we can use a regression, and this is a geo and environmental sciences. So there are a lot of examples. You can find it over the internet, and you can understand the concept of SVM very easily with the help of any one of these examples. So the SVM found many applications in many fields. So you can do it. You can learn SVM in using or with the help of any one of these examples. So you have to remember this application, but the basic idea is to just generate a hyperplane. So here we are just going to discuss about the what is the basic idea of the spore vector machine. And here we are first considering the linear classifier. And here there is the net. This one is a dark blue. There is a dark blue samples are there, which represents the positive one, and the holes, which is filled with the white color, which represents the minus one. So there are only two classes are existing. And now the question is that how would you classify this data set? So this is one of the important question, and again challenging. And yes, uh, someone can do this by separating these two classes with this line. So this one is your first case. This is a case, or you can simply write it as a one. This is the first case is there, and someone else can also separate these two class categories like this uh, with the help of this line. So this is the second case. So in a third case, someone can separate these class categories with the help of this line. This line. So this is the third case. So there are a number of cases are there. So at the end, we can see that there are a number of options are there, and which are countless basically. And there is no any specific number of these cases. But yes, you can decide any one of these lines so that we can separate the two class categories. So it's a best way to to create a hyperplane. So what is a hyperplane? That in order to understand the concept of a hyperplane, we have to understand the margin. So there is a maximum, not a maximum margin. First, what is a margin? Margin is a linear classifier as the width that the boundary could be increased by before hitting a data point. So here you can see that in this there is a last one. Here you can see that this is a basically intersecting point. So we have to avoid such kind of a intersect point. So in this case, they have just a little bit rotate anti-clockwise. They have just rotated this anti-clockwise to just remove to avoid the intersection of a data points. So these are generally referred to as the data points, and we have to select this kind of a plane. That is a satisfactory. Fine. And now, what is the maximum margin? Okay, we have to create a margin. We have to create a there is a hyperplane, and in order to create a hyperplane, we have to select the maximum margin linear classifier. This one is this one that whatever we are doing, that is an example of a linear classifier, and we have to select the maximum margin. Here you can see that the yellow line, this yellow line and this yellow line, and these are actually representing the margin. And so here you can see that there is a difference between these two uh, between the width of these two margins. And this one is a very less margin is there, and in this case there is a little bit larger margin is there. But yes, we have to just select a line which is exactly in between these two points. And here you can, one I have marked a data point, or we can say it as there is a class 1 data point is marked with the green circle, and the class 2 data points marked with the uh, brown circle. So you have to just select a line in exactly in between these 2 points. So this one is also a, yes, this one is also a class 2 data point. So these type of data points help in creating the hyperplane. So these are also actually act as a support vectors. So these are also referred to as a support vectors to create the hyperplane. So here you can see that there is a line is there, but no data point is intersecting with it. But there is a margin is created with the help of by intersecting the data points. So this one is a maximum limit of the margin, and this one is a maximum limit of this margin. So we can say it as a the maximum margin linear classifier is a linear classifier with the maximum margin, and the simplest, and this is a simplest kind of a SVM. So just wait for a moment. Okay. Yes. Now, hopefully you are able to understand this concept. There is a first, what is a support vector machine? The support vector machine is a supervised learner, and the basic idea of the support vector machine is to create this type of a hyperplane. And now these are the applications, and these are the linear classifiers. Uh, this is basically you can understand with this. This is a continuous example, so you no need to worry about it. And these are the basically two classes are there. How we can create? There are a number of cases are there, and in order to create a such type of different examples, we can create this kind of a example. And this is a called hyperplane. There is a creation of the hyperplane. Now, how we can create the hyperplane? So there is a one more term is there. There is a this equation which helps in to create this type of a line. And I will not explain where x is a vector, w is a normal vector, and v is a scale. And in order to understand the mathematical there is a, you can say it as a, there is a mathematical proof of how to write this equation for this line. You can just please go through this link, and you will able to understand the how we are writing this type of equation. So in a simply as that you can understand that why we are writing this line is as a wx plus b is equal to 0. uh, that there is ultimately goal we have to implement. This is basically, this one is not a question of a machine learning, and this is a mathematical problem. How we can just write down this type of a line. So in order to, there is a next part. There is a selection of the hyperplane. So this one is a very important slide. So how we can select the hyperplane? The best choice will be the hyperplane that leaves the maximum margin from both classes. And here you can see that we have just randomly marked two lines. So you have to select the one from these two lines. The first one is a red and second one is a green. And here you can see that this one is your just one second. Okay, and here you can see that this one is your main line, what you have made. Now you have to select the margin, or you can select the margin. You just have to increase the margin towards the class 1, and you have to increase this margin till it will not intersect with the data point of class 1. This one here you can see that this one is a data point. Once it intersects, you have to stop that margin. And similar, you have to do it with the on the other side. And here you can, once it intersect with the another data point or a data point of a second class, you have to stop this point. You have to stop the increasing this margin. And here you can see that the this margin is generally defined by the z z1. And in another case, when we are considering the grain, we have just marked this line and we start increasing the margin. And we have to increase this kind of a margin till the till it will not intersect with the data point of class 2. So this one is a data point for the class 2. And once it intersect, you have to just stop it here. And definitely you can't assume it over there because it actually crosses the data point. So that's why you have to just increase the margin till it will not intersect with the data points, and similar for this way. And this the margin, and there is actually you have to be sure that the margin must be equally increased in both sides. So that is a concept you have to remember it. And this one is a referred to as a Z2. Now, my question is, now there is a question. Now, which one has a more margin, Z1 or Z2? And as you can see that there is a example one, there is a, and this one is a example two. And definitely the margin of the Z2, here you can see that the margin of Z2 is higher as compared to the margin of Z1. So this is a concept that we can just write it here. There is a Z2 is the margin of the Z2 is greater than the margin of Z1. So first, this is the first concept. You have to select a line which is actually defining the correct hyperplane. So once you have selected on the basis of margin, and you have to do the calculate the support vectors. And in order to select the support vectors, and yes, in order to select the support vectors, this one is a hyperplane. Basically, this z here you can see that this z is basically defining the hyperplane area. So yeah, we can also mark it as a this one, and on this end we can just write it just drawn here. There is a not a actually I have not made a straight line, but you can assume it as a this is a straight line. So here you can see that this is a margin, and which is represented by the z. So this one is the equation for this line, and which is very similar to the this, that is a wx plus b, and similar there is a wx plus w, that is a w naught. So this is just a little bit different representation, nothing else. The entire basic concept is equally same. So so what is a z? Z is actually a that is a division of the uh, this equation upon the support vector, and this is actually referred to as a support vector, this w. And still your question begins with the this point. So your if the equation that is if this equation whatever we are talking about, if this equation is greater than or equal to 1, then we can say it as a that is a class 1. And if it is a less than minus 1, less than or equal to minus 1, then we can say it as a class 2. So according to me, this one is greater to 1, then you can just zoom it here. There is a 1 is there, then is a minus 1 is there. So there are two class categories that you can define, and according to there are two Z's are there. There is a Z1. There is a difference from this point to the this. You can just write it as a, if Z is a 1, 1 upon 4 vector, there is a 1 support vector is there. Here you can see that this one is a 1 support vector and this one is another support vector. So first, you must have to remember that we are calculating the total margin, and you just have to add these two support vectors, and at the end you will get the this total maximum margin, and this is the minimum. Okay, once you have minimizes this term, that will automatically maximize your separability. And here there is a okay, how you can minimize this? You can minimize the support vectors with the help of a, this is a KK technique. There is a some algorithm is there which can be implemented with the help of the Lagrange multipliers, and this is the entire concept of a KKT. So here there is not actually in-depth concerned with the code vector machine, but that is a separate equation that or a supplementary equation which is added with the sport vector machine. But according to the sport vector machine, you have to remember this point, and how we are calculating, we are defining the two class categories. That is important, and this is a total margin. And if you want to minimize this or maximize the separability, then you can do it with the help of this KK technique using the Lagrange multipliers. So this is a little bit tricky game is there. You can do it with the help of this. But however, you have, once you have selected the margin, then yes, you have to identify the support vectors. And this is another example which is you can also go through this example with the help of this. This is a video link for this PPT. This slide and this slide. So both slides can be covered through this YouTube video. So how is it working? Here we have assumed there are 2 points are there. So the one point is 1 we have selected. There is a 1 is there, and the 1 that is, we can write it as a 1, and there is a 2 and there is a 3. And so this is a 3, this is 1, this is like 2 is there, there is a 1 and 2. So you can also write it as a 2, 3. So this is a, that is a data point. There is a first data point is there and the second data point is there. So you can just mark it as a hyperplane. Okay, once you have marked, there is a weight vector. Yes. How you can compute the weight vector? It's very easy. You have to select the highest and you have to subtract with the least. So the highest is a 2, 3 and the least is a 1, 1. So there is a 1, 1 and there is a 2, 3 is there. Then once you have just subtract the 2 minus 1, you will get A. That is a vector. And once you have minus 3 minus 1, you will get the 2. So you can write it as a 2A. So A is a vector. And so the at the end, we can conclude that they, let's see. Okay, sorry. You can just write it as a weight vector as a and 2A. So one. Just wait for a second. Hello. Okay. Let us start with this point. Okay. Now, here you have select the. Okay, you have to write the equation. Okay. You have to write the equation. Here you can just write it. Once you have identified the vectors, you have to write the equations for this plane and for this plane. So accordingly, there is a which, and this is actually represented by the -1, and this one is represented by the +1. Or here you can see that, and this one is the equation which can easily be derived. There is a gx. There is a gx is there. There is a gx which is equal to the -1 for this 1 1, and this one for the 1 for the sorry this one for the this equations. So we can easily write this equation from 2 3, and just you have to write it as a 2a, and plus there is a because there is a 3 into 2, there is a 6 a is there, and plus you can just write it as a w naught, and this is also a gx. You can just go to this point, and once you got my point, then there is a gx is there. There are two, so we are just putting the actual values with respect to these planes. These two planes are there, and with respect to these two planes, just we are putting these equations, and we are just using that point, that is a for 1 1, and this one for the 2 3. And then there is a w naught is there. There is a we have to just write it as a, and you can conclude it. Yeah, you can conclude this w naught. Okay, there is a we have to just clear this up. Okay. Okay, here you can see that how you can identify the w naught. You can easily identify the w naught with the help of this equation, and this is a very easy. And once you get the value of w naught, you can put it into the there is here what we have done. Yes, we have put it the value of w naught into the equation 1. So 1 second, you have to remember this one is your first equation, and this one is your second equation is there, and you have come to this point with the help of second equation. And once you will find out the w naught, then you can just put it into the equation 1. So here we have just put the value of W naught, and this will add up with the A plus 2A, which is equal to the 3A. And here we have just put the value of W naught, that is, which is equal to the 1 minus 8A. So we have put it here. So which is equal to the minus 1. So at the end we can conclude it as a, that is 2 by A. And once we get this A, then we can put it into this value. Actually, there is a R ultimate goal to identify the W naught. So there is a W naught is there, then we can just write it as a this one. And you can use your tricks how you can identify the value of W naught. That is up to you. And we can just say it as a R vector is, there is a W which is equal to the A and 2A. Now we can just write it as a weight vector 2 by A, which is right from the from here. And there is another vector is there, that is 2A, which is multiplication. That is 2 into 2, 4, that is 4 by 5. You have to multiply uh, multiply by 2, then you will get the another 2. So these are actually referred to as a support vectors. So this is a point, fail point. You have to remember that how we can identify the hyperplanes with the help of the support vector. And this is the equation for the line that we have done. And yes, there is a, yeah, we can put it over here. Yeah, one second, please hold for a second. Yeah, hello. Am I audible to you? Okay, we are just found that there is one second. Now here we can just written here. There is a these are actually referred to as a support vector, and this is a equation. Then which is we can write it here. That is a this is the actual value that we have calculated, because this is a 2D matrix. Then we have to write the W. There are two. There is a 2 by 5 is there. So we have put it here. There is a 4 by 5 is there. And then we have calculated the value of W naught, which is equal to the minus 11 by 5. So we have put it here. So at the end, we have just take the common. There is 2 by 5. Once we have taken the common from this, there is a 2 by 5, we will come to this point. So this is the entire concept of a support vector machine, and this is actually referred to as a support vector machine. And if you want to explore about, there is not more, but yes, this is a basic entire concept of a support vector machine. But still, if you have not got any point, then you can just ask me, and you can also go through this video. So this is actually provide the great example of a support vector machine. Now, this is up to we have done the linear part and linear support vector machines, and there is another non-linear SVM. So, which is uh, in which the datasets that are linearly separable. Yes, here you can see that these are the some examples which are related to the support vector machine. And this one, that is an example of a linear spin scale. And okay, yes, here you can see that this one is a one class, and this is a another class. So because there is a no any data point of a class one here, so we can easily differentiate these two classes with the help of or by creating uh, a hyperplane over there. So this is a maximum margin. So this is a we can say it as a Z1, and this one is referred to as a Z2. And this is maximum margin, and we can just intersect with a point. We can just we can do it very easily. But yes, there is another case is there when there is a data point on the other end. If there are some data points are still existing on the other side of the class 2. So by just putting the hyperplane over there, we can't uh, do this very easily. So in order to make it easy, we have to just plot the two-dimensional two-dimensional graph. Or this they have written there. There is a hyper. There is a not hyper. There is a higher dimensional graph which is more than 1D. So here we have just designed the 2D plot, and we can here we can see that this is a 1D plot, and we have converted it to the 2D plot. And once we have converted 2D plot, then we can easily create the hyperplane in between that. So according to this concept, we have to just remember that we can easily convert the one dimensional there is a into the two dimensional, or we can just apply the sport vector machine by mapping the data into the higher dimensional space. Or there is another cases there where they have just considered this one. There is a two-dimensional graph is there, and you can see that, and you can just put it here over the put it the circle. So yes, you can do it, but there is a another case is there. You can create the hyperplane by converting into the three-dimensional. So there is a 2D problem, and we can solve these 2D problems with the help of by converting into the 3D plot. And here you can see that there is a 3D plot is there, and you can just create it a line in between these two class categories. So there is some different categories of the SVM by which we can just create the hyperplane, or we can just separate the one class category from the another class category. So this is the entire concept of the SVM. There is a sport vector machine, and if there is any question, then you can just please ask. And okay, now if you have any question, then you can just please ask, and we have enough time to solve your queries. Yes, please. If you have any question, then please write it on a chat box. And uh, One second, please hold for a second.